There is a feeling you get when you look up at the night sky in a truly dark place. It isn't just wonder. It isn't just beauty. If you stare long enough, if you let your eyes adjust to the crushing weight of that silence, you feel something else. You feel a very specific, primal kind of fear. It is the fear of being small. But more than that, it is the fear of being late. For thousands of years, we thought the universe was a static stage, a backdrop painted for human history. We thought it was waiting for us. But recently, in just the last few years, we have started to realize that the universe isn't waiting. In fact, it is running away. We have built machines, great golden mirrors floating in the cold void, to peer back to the very beginning of time. And what we found there shouldn't exist. We found monsters. We found galaxies that are too bright, too big, and too old to be where they are. It is as if we walked into a nursery and found fully grown adults waiting for us in the cribs. To understand the universe is not just to learn about stars and black holes. It is to confront a single terrifying possibility, that we are trapped in a bubble of information, a reality cage that is defined not by what we can see, but by what we are physically forbidden from ever knowing. Today, we are going to stop looking at the stars as objects. We are going to look at them as ghosts. We are going to peel back the curtain of the cosmos to understand the terrifying architecture of our reality. We are going to find out where the edge is. And we are going to ask the question, what is on the other side? This is not just a story about space. This is a story about the limit of your reality. Chapter 1. The speed of causality. To truly understand the universe, you have to break your human intuition. Your brain evolved to understand rocks, rivers, and tigers. It evolved to understand things that happen now. If I throw a rock at you, you see it move. The cause and the effect feel instantaneous. But the universe doesn't work like that. The universe is a machine built on lag. Imagine you are standing in a dark room. You turn on a flashlight. The beam hits the wall instantly, or so it seems. But if that room were the size of the solar system, you would turn on your flashlight and you would wait. You would wait minutes for the beam to hit the wall and minutes for the reflection to come back to your eyes. You would be seeing the wall not as it is, but as it was. This is the first rule of the cosmos. To look out is to look back. When you look at the moon, you are seeing it 1.3 seconds in the past. When you look at the sun, you are seeing it 8 minutes in the past. If the sun were to vanish right now, completely disappear, you wouldn't know. You would still feel its gravity. You would still see its light, and you would still feel its warmth for 8 whole minutes. You would be orbiting a ghost. You would be living in a past that no longer exists. Now, extend that terrifying logic to the rest of the universe. The nearest star, Proxima Centauri, is 4 years away. When you look at it, you are seeing light that left it 4 years ago. But that is nothing. That is the neighbor's house. Look deeper. The Andromeda Galaxy, that faint smudge you can see with the naked eye on a clear night, is 2.5 million light-years away. The light hitting your retina tonight left Andromeda before humans existed. It traveled through the void, while dinosaurs rose and fell, while ice ages froze the earth, while civilizations built pyramids and skyscrapers. That light traveled alone in the dark for 2.5 million years just to end its journey in your eye. But this creates a problem, a paradox that keeps astrophysicists awake at night. If everything we see is in the past, then we have never, not once, seen the universe as it is right now. We have no idea what the universe looks like today. Betelgeuse, the giant red star in Orion's shoulder, might have already exploded. It might be gone, but the news of its death hasn't reached us yet. We are trapped in a bubble of stale information. We call this the observable universe. It is a sphere of reality centered on you. It extends about 46 billion light years in every direction. That is the limit. That is the wall. Beyond that sphere, there is more universe, likely infinite amounts of it, but we can never see it. The light from those distant regions hasn't had enough time since the Big Bang to reach us. We are living in a cosmic video game where the map only loads as far as the speed of light allows. And just like a video game, there is a render distance. But here is where it gets scary. The render distance is shrinking. Chapter 2. The Great Running Away. For a long time, we thought this bubble was growing. We thought that as time passed, light from further and further away would finally reach us, and more of the universe would be revealed. We thought the map would keep loading. We were wrong. In the late 1990s, we discovered something that shattered our understanding of physics. We discovered dark energy. We found that the universe isn't just expanding. The expansion is accelerating. Space itself is being created between galaxies faster and faster every second. Imagine drawing dots on a balloon and then inflating it. The dots move away from each other. Now imagine the balloon is inflating faster than an ant can walk across the surface. There are galaxies near the edge of our vision that are moving away from us faster than the speed of light. Wait, you might say. Nothing can travel faster than light. You are right. Matter cannot travel through space faster than light. But space itself? Space has no speed limit. Space can do whatever it wants. The space between us and those distant galaxies is stretching so fast that the light they emit is trying to run up a down escalator that is moving too fast. That light will never reach us. It will travel forever, fighting against the expansion of space until it fades into nothingness. This means that every second you have been watching this video, thousands of galaxies have crossed a chaotic threshold. They have passed the cosmic event horizon. They are gone. We will never see them again. They have been disconnected from our reality forever. If there are civilizations in those galaxies, beings looking back at us, they are now lost to the void. We can never talk to them. We can never visit them. They have fallen off the edge of the world. And this leads to a terrifying realization about the future. Billions of years from now, the expansion of the universe will be so fast that all other galaxies will be pushed beyond our horizon. The night sky will go dark. Future civilizations born on Earth, or whatever planet we inhabit then, will look up and see ... nothing. They will see only their own stars. They will think the entire universe is just their own galaxy. They will have no evidence of the Big Bang, no evidence of the expansion, no evidence of other galaxies. They will build their physics, their religions, and their philosophies based on a lie. They will think they are alone in a static, eternal darkness. And that makes you wonder, what have we already lost? What parts of the universe have already raced away from us before we were even born? What truths about the cosmos are missing from our sky because we showed up 5 billion years too late to see them? We might be trying to solve a puzzle where half the pieces have already been thrown away. Chapter 3. The Monsters in the Dark. But we don't need to look at the future to find things that don't make sense. We just need to look at the beginning. In December 2021, humanity launched the James Webb Space Telescope. It was designed to be a time machine. Its golden mirrors catch infrared light that has been stretched by the expansion of space as it traveled for billions of years. We wanted to see the cosmic dawn. We wanted to see the moment the first stars turned on. Our theories were solid. We believed that after the Big Bang, the universe was a hot soup of particles. It took hundreds of millions of years for this soup to cool down, for gravity to pull gas together, and for the first baby galaxies to form. We expected to see small, messy, chaotic blobs of gas. That is not what we saw. James Webb pointed its eye at the darkness, at a time merely 300 to 500 million years after the Big Bang, and it found the universe breakers. It found massive, fully formed galaxies. It found galaxies with spiral arms, ordered structures, and supermassive black holes that were millions of times the mass of our sun. These things should not have been there. It is mathematically impossible for gravity to have pulled that much matter together in such a short time. Imagine walking into a kindergarten class and finding a child who is 6 feet tall, has a full beard, and is teaching a class on quantum mechanics. You would know that something is wrong with your understanding of human biology. That is where we are with the universe right now. The standard model of cosmology, the story we have been telling ourselves about how we got here, is cracking. Some scientists are now whispering about something called primordial black holes. They suggest that maybe the universe didn't start with smooth gas. Maybe it started with billions of black holes that formed instantly after the Big Bang. Maybe these monsters acted as the seeds, pulling matter together faster than we thought possible. Or perhaps the universe is older than we think. There are fringe theories gaining traction, theories that suggest the Big Bang was not the beginning, that it was a bounce, a restart, that our universe is just the latest cycle in an eternal heartbeat of expansion and contraction. But there is a darker interpretation, one that ties back to the idea of the render distance. If we are living in a reality that is fundamentally information-based, as suggested by the simulation hypothesis or the holographic principle, then maybe the anomalies we see at the edge of the universe are artifacts. Maybe the universe generates detail only when it needs to. When we built a better telescope, when we increased the resolution of our observation, the universe had to render more detail. And maybe, just maybe, the procedural generation is glitching. We are seeing galaxies that look too perfect for their age, because the rules of the simulation favor efficiency over chronological realism. It sounds like science fiction. But in 2024 and 2025, physicists have been debating whether information is a physical state of matter. If information has mass, if the universe is fundamentally made of data, then the impossible galaxies might be a clue that the code of reality is optimized. Chapter 4, The Great Filter of Time. Let's bring this back down to Earth. Let's bring it back to you. Why does any of this matter? Why does it matter if a galaxy is moving away or if a star is too big? It matters because it tells us where we stand in the story. For decades, we have been obsessed with the Fermi paradox, the question, where is everybody? If the universe is so old and so big, why haven't we heard from aliens? Why is the universe so quiet? Usually, we think the answer is distance. They are too far away. But understanding the universe's expansion offers a scarier answer. We are quarantined by time. Civilizations might rise and fall all the time. But because of the finite speed of light and the expansion of space, we are locked in our own temporal cell. A civilization could have thrived in the Andromeda Galaxy 1 million years ago. They could have built a Dyson sphere. They could have shouted, "Hello," into the void with radio waves of infinite power. But we wouldn't know. The signal hasn't reached us yet, and by the time it does, 1 million years from now, we might be gone. The universe is not a community. It is a series of lonely islands separated by an ocean that takes millions of years to cross. We are shouting into a canyon, but the canyon is so wide that the echo won't come back until our species is extinct. This isolation is the true nature of the cosmos. It is not hostile. It is indifferent. It places a speed limit on connection. It ensures that no matter how hard we try, we can only ever touch the tiniest fraction of reality. Chapter 5. The Vacuum Decay, the end of the script. We have talked about the beginning. We have talked about the edge. Now, we must talk about the floor. To understand the universe, you have to understand that nothing is not empty. Take a box, suck all the air out of it, shield it from radiation, cool it to absolute zero. You have empty space. But it isn't empty. It is boiling. Quantum fields are vibrating everywhere. Particles are popping in and out existence. This vacuum energy is the foundation of reality. It is the floor we are standing on. But what if the floor is rotten? There is a theory called vacuum decay. It suggests that the energy level of our universe, the setting of the vacuum, is not the lowest possible setting. We are resting on a ledge, not the bottom of the valley. We are in a false vacuum. At any moment, anywhere in the universe, a quantum fluctuation could occur. A tiny bubble of true vacuum could form. Inside this bubble, the laws of physics would be different. The constants of nature would change. Atoms wouldn't hold together, and this bubble would expand. It would expand at the speed of light. Because it moves at the speed of light, we would never see it coming. One moment, you are drinking your coffee, looking at the stars. The next moment, instant deletion. No pain. No warning. Just a rewriting of the laws of physics that erases biology, chemistry, and matter as we know it. This could have already happened 1 billion light years away. The bubble of doom could be rushing toward us right now, but we won't know until it hits us. This is the ultimate lesson of the universe. It is built on uncertainty. It is built on horizons we cannot see past. We are small creatures living on a fragile rock, drifting through a cosmos that is hiding its true face from us. We are seeing a delayed broadcast of a show that might have already been canceled. But there is a flip side to this terror. A strange kind of hope. If the universe is hiding things from us ... If the horizon is a limit, that means there is mystery left. In a world where we have mapped every inch of the earth, where we have categorized every animal and measured every mountain, the universe remains the last great unknown. The fact that we cannot see the edge means the edge might be infinite. The impossible galaxies that James Webb found are not just errors in our math. They are invitations. They are telling us that we are wrong. And in science, being wrong is the most exciting thing that can happen to you. Being wrong means there is more to discover. We thought we knew how the story started. The universe said, "No, you don't. We thought we knew how the story ends." The universe said, "Wait and see." So, how do you understand the universe? You don't, not yet. You simply witness it. You accept that you are a traveler in a fog, holding a small lantern. The lantern illuminates only a few steps in front of you. You cannot see the destination. You cannot see the path behind you. But the light is yours. And for as long as it burns, you get to be the part of the universe that is waking up. You get to be the eyes of the cosmos, opening for the first time, trying to see itself in the mirror. And even if the reflection is terrifying, isn't it better than closing your eyes?